Visible?
Sir, audible.
Okay. Screen is visible.
Sir?
Screen is visible. Like I'm sharing the.
Visible, sir.
Okay.
Visible, sir.
Okay. So today's session, I will discuss the effect of the source inductance. So last sessions I have discussed, like all previous session without effect of source inductance, we have discussed all the different type of converters like half wave and full wave. Okay. So one by one, effect of source inductance I will discuss for all the converters. So here this diagram is for single pulse converter, means single phase half bridge converter. Okay. So here a freewheeling diode is given and this is the thyristor. So if this inductance will not be there, then what will be the waveform? That first I'm going to draw that waveform. So you see the source voltage Vs. Okay. So this is without source inductance. So what will be the current? So let's say I'm triggering at alpha. This is alpha angle. Okay. So output voltage will be like this, alpha to pi. Then this is 2 pi. And here it will be like this. Okay. So what will be the current through the thyristor? The thyristor current will be from, this is alpha. So thyristor current will be from alpha to pi. Okay. And what will be the diode current? So diode current will be the remaining portion. So this is IT and this is ID, diode current. So diode current will be for remaining portion. Okay. Here to here and here to here. So you can say that this thyristor is conducting for pi minus alpha and this is diode is conducting for pi plus alpha in one cycle. Okay. But what will happen due to the source inductance? Inductance doesn't allow sudden change in current. Okay. So this thyristor current cannot go at instantaneously from 0 to, it cannot go from 0 to I naught. Okay. And this one directly cannot go from I naught to 0. So what will happen? Due to the source inductance, here a overlapping kind of thing will happen. Okay. So this both currents I'm drawing together. Let's say this is uh, thyristor current. So it will be like this, and the diode current also happen like this. So this is alpha. After alpha, what is happening? This thyristor current is going from 0 to I naught, and diode current is coming from I naught to 0. But this will not go instantaneously to 0 and I naught. This period is called as overlapping period. Okay. This is because of the inductor, source inductor. Okay. In ideal case, instantly it will go from I naught to 0 and 0 to I naught. Okay. Like diode current will go from 0 to I naught, and in this thyristor current will go from I naught at this instantaneously. But due to the source inductance, what is happening? It is creating a slope like this one. So if this is alpha, after mu angle, this thyristor current is settled to I naught and diode current will become 0. Okay. So this period is called as overlapping period. Is it clear up to now? Why this is happening? Is it clear?
Sir, once again, sir.
See, this normally what will happen, like instantaneously, this current are exchanging between thyristor and diode. Okay, when this thyristor will be turned off, like let's say at alpha, I am firing the thyristor. Okay, it will conduct up to pi. At instantaneously pi, what will happen? Thyristor current will become 0 and diode current will start, it will to I naught. Okay. So that is happening instantaneously, like exchanging of current. This is load current. Okay. So load current will be sometimes supplied by the diode, freewheeling diode, or sometimes it will be supplied by the thyristor. So this exchange is happening instantaneously if source inductance will not be there. Okay. But if source inductance will be there, what will happen? It will not allow sudden change in current. Like instantaneously, current will not become 0 to some I naught or I naught to 0. That's why what is happening, this like load current I naught, let's say here I naught, this is the like this is thyristor current IT, and this is diode current. Okay. So at this instant I am discussing here. So here what will happen? Diode current will become 0, I naught to 0, and thyristor, one second. This is diode current. So diode current is from I naught to 0, and thyristor current will become 0 to I naught. But that will not happen instantaneously. It will happen after some mu angle. So it will create a slope. It will take some time to reach I naught. This is why, because of inductor. Is it clear?
Clear, sir. Clear.
Okay. So considering this, I'm going to draw the output voltage. So one second. So this diagram I'm going to omit. Next page I will draw. So one second. Hmm. Okay. So one by one I'm going to draw the output voltage and currents. So this is the, let's say, source voltage, first source voltage, Vs. Okay. And this is, let's say, alpha angle. Okay. And here I'm drawing both the currents together, diode current and thyristor current. So thyristor current I'm drawing with yellow color. So thyristor current, it will be 0 before this one. It will go to I naught. Okay. And this current, uh, like diode current, it will be I naught here, and it will go to 0. Again here at I, what will happen? Again our thyristor current will become 0 here. So it will not become 0 instantaneously. It will make a slope here also, and this current also, it will make a slope here also, and both time overlapping angle will be same. Okay. So up to here, this will be the total duration. So this is mu overlapping period. Here also it will be mu. This blue color waveform is, this is diode current, and this yellow color is thyristor current. Okay. Yellow current is thyristor current. So instantaneously it is not becoming 0 to I naught. This magnitude is I naught. So instantaneously it is not becoming 0 after I naught. We are firing at, we are firing the thyristor T. Okay. So after this instant, it will make a slope and it will reach to I naught after some overlapping angle mu. Okay. So what will happen during this period? All T1 will be on, T will be on, and D will be on. Okay. And here also if you will see, T will be on and D will be on. So if both will be on, what will be the output voltage? Can anyone tell? If during overlapping period, since this is also conducting and this is also conducting. Okay.
At 0.
Yes. So if diode will conduct, output voltage will be 0 because this will short. So previously, what should be our output voltage waveform? It should be like this one. Okay. But because of overlapping, what is happening during this shaded region, our output voltage will not appear. It will be 0. So actual output voltage waveform due to the source inductance will be this one. Okay. So this period is mu. This will be our output voltage waveform. Okay. So now we can derive the equation here. So one equation we can write, VL is equal to Ls into dis by dt. Okay. So alpha to mu, alpha to alpha plus mu. So what will be this point? If this point is alpha, this point will be alpha plus mu. Okay. So we can integrate V. What is VL will be what during this period? Can anyone tell? It will be, no, this if this will be on. Okay. If this will be on and both will be on, so both will be on means what? If this will short, okay. During overlapping period, I am writing. So overlapping period means Vs will be LDI by VL will be Vs. This is plus, this is minus. Okay. So VL will become Vs during the overlapping period since both are on. So what will be the source voltage? Source voltage will be LDIS by dt. Okay. So this one we can integrate alpha to mu plus alpha. Okay, and this will be Vm of sine omega t. Okay, dt equal to L d is integral. So I naught, if you'll see, it will go from 0 to I naught. So you'll say here 0 to I naught. Is it clear up to now, this equation? Anyone ask? I will reply. Is it clear?
Sir,
How
once
I
again, sir.
see, during the overlapping period, what is happening? T is on and D is on. Okay. So both is on means what will be the circuit? Circuit will be like inductor, a voltage source, okay, and this will be sorted. And this is the current, source current. This is Ls. So if you see the inductor voltage, what will be the inductor voltage? So if you apply KVL in this one, inductor voltage will be, VL will be equal to Vs. Okay, so we can write as Vs is equal to LD Is by dt. Okay, and during this is like alpha, and this instant is alpha plus mu. Okay, since this duration is mu, so this instant will be alpha, this instant will be alpha plus mu. So we can integrate this one. So Vs into dt integral. So Vs is what? Vm sin omega t. This sinusoidal. Vm sin omega t. I am integrating from alpha to mu plus alpha. Okay, and this side it will be L into integral dis. Okay, and that will be here initially is was 0 and it will go to I naught after at this instant. So what will the limit of the is? That will be 0 to I naught. Is it clear?
Yes, sir.
Okay. So now we can simplify this one. So what will be the integral? The Vm will take outside. It will be minus cos omega t divided by omega. So what will be the limit? Alpha, alpha plus mu. Okay. And here it will be Li0. It clear? That this side I naught di means it will integral will be I and limit will be I naught minus 0. So it will be Li naught. Okay. So further we can simplify this one. This is Vm here. Okay. So Vm into minus cos omega t. What is the value of here? It will be alpha to alpha plus mu. Alpha to alpha plus mu will be Li0. Is it clear up to now? So it will be Vm. Okay. Here it will be cos alpha minus cos alpha plus mu is equal to, here omega it will go, omega Li naught. So it will be omega Li naught. Is it clear up to now? Can anyone reply?
Clear, sir.
Okay. So both side I am going to divide by 2 pi. Okay. 2 pi, here also 2 pi. Otherwise here omega will be 2f L 2 pi f. Okay. So that will be this one. So f L I naught. So this side it will be f L I0. And what will be the right hand side? It will be, here we can write. So what will be this part? This will be Vm upon 2 pi. Okay. Cos alpha minus cos alpha plus mu. Okay. So what is this integral? This is, we have calculated the shaded region. So shaded region means the drop in voltage due to inductive effect. Okay, so that we can call as delta Vd0. Why I am calling it delta Vd0 means it is the drop, like shaded area I have calculated here. So drop due to the inductive effect, that will be called as delta V0, and which is equal to FLS I0. Okay, and what is this value? If you'll see, normal case the output voltage is Vm upon 2 pi 1 plus cos alpha without overlapping. Okay. So if alpha is equal to 0, what will be this value? This will be
m by 2 pi.
no Vm by pi, because 1 plus cos alpha 2 will cancel, so it will be Vm by pi. So that at alpha is equal to 0, that we will define as alpha is equal to 0, output voltage at alpha is equal to 0 is VD0. I'm defining this one. Okay. So what will be this value? This value will be VD0 by 2. Okay. So we can write as delta VD0, okay, is equal to VD0 by 2 cos of alpha minus cos of alpha plus mu, where VD0 is equal to VO without LS effect at alpha is equal to 0. Is it clear? So this is a generalized equation for all the converters. Okay. In all converters, we can derive this equation.
Sir, I have one doubt.
Okay, you can ask.
Sir, generally we integrate with respect to d omega t, but here we are integrating with respect to dt.
Okay, I'm integrating with respect to dt. It's correct only. So what is your doubt? See, VL is equal
Sir,
to
why we are doing this?
no. See, VL is equal to L di by dt. This equation we are using. Okay. So this equation itself dt is there.
Okay.
This equation here is using with respect to this equation we are doing the integration. Okay. So here omega t, because here dt is already there, no? So Vs will be integrate with respect to dt only, but actual limit is angle, because omega t what? Omega t means angle. Okay. So omega t will limit will put angle only, alpha plus mu. Is it clear?
Yes, sir.
Okay. So this we have to remember. This is the generalized equation. So what is the VD0 for single phase half bridge converter? V0 will be 2 Vm upon pi, no, Vm upon 2 pi, that will Vm upon 2 pi, 1 plus cos alpha. VD0 will be Vm upon pi. So at alpha is equal to 0. VD0 by 2 will be Vm upon 2 pi. So that's what we have derived. Vm upon 2 pi means VD0 by 2. The meaning of this one is VD0 by 2. Okay. So this is the generalized equation for all the converters. 1 pulse, 2 pulse, 3 pulse and 6 pulse. For all converter, we can use this generalized formula where delta VD0 equal to VD0 by 2 cos alpha minus cos alpha plus mu. Now we can derive the output voltage. So what is the output voltage? V0 will be normal V0 minus delta VD0. Is it clear? This is a reduction in voltage. Okay, this shaded area I have calculated. So what will be the actual output voltage? So without inductive effect minus delta VD0. Okay. So what is that voltage? Vm upon 2 pi 1 plus cos alpha minus this value how much? Here we have already Vm upon 2 pi cos alpha minus cos alpha plus mu. Okay. So Vm upon 2 pi cos alpha minus cos alpha plus mu. So that will be Vm upon 2 pi 1 plus cos alpha plus mu. So this will be the output voltage. Okay. Is it clear? Is it clear to all?
Sir, please explain one more time, sir.
Which one? This equation. This one or
Yes,
from previous one?
yes, sir. Previous one.
See, I'm once again explaining from starting. Okay. See what is happening due to the source inductance. Like normally current will be from I0 to 0 and 0 to I0 instantaneously. But what is happening? Because of the overlapping, because of inductive nature, because inductor will not allow sudden change in current. Okay. So that's why here exchanging of the current between this diode and thyristor will not happen instantaneously. So here this yellow color is thyristor current. It will initially it will be 0 here. Like it will, if it source inductance will not be here at this alpha instant only, it will go from 0 to I0. But because of inductor, it is taking some time, and after mu angle, it is reaching here. Similarly, the diode current from here to here, to make it 0, it is taking mu also. So this is the overlapping angle. Okay. What will happen during the overlapping period? All that this thyristor and diode will be turned on. So due to that, the output like this diode is on, means output voltage will be 0. Okay. That's why this yellow color should be the waveform without the source inductance. But due to the source inductance, this mu period is overlapping period. Here diode is conducting, so that period output will be 0. Okay. So I have calculated the voltage for this shaded region. Okay, alpha 2, this point is alpha and this point is alpha plus mu. So here to here, what will be the average value of the output voltage? Okay, is it clear? So that
Yes,
will,
sir.
so that I have Vs is equal to LDI by dt. Here I have integrated this one as per this equation. Okay, so I'm getting this value Vm into cos alpha minus cos alpha plus mu. Further, Vm upon 2 pi here, and cos alpha minus cos alpha plus mu, this equation. So this is called as reduction in voltage due to the overlapping. Okay, which is equal to F Ls I naught. F is the supply frequency, Ls is the source inductance, and I naught is the load current. Okay,
Average.
average output current. So that will be here. We will consider the ripple free current only. Okay, all the analysis will consider ripple free only. Without ripple free, it cannot, analysis cannot be possible for the source inductance. Okay, so this is the delta VD0. Delta VD0 means that shaded region voltage. This was the shaded region, this was the actual voltage. So this shaded region voltage already we have calculated, that is this one. So what will be the actual output voltage? So actual output voltage means voltage without that effect,
Source inductance.
that is this voltage minus delta VD0. Okay, so if we are subtracting this one, we are getting 1 plus cos alpha plus mu. Okay,
Oh,
so now I am going to write the summary for all the converters, like one by one. So two equation we have to memorize. V naught will be for this one pulse. Okay, V naught will be VD0 by 2. Here if you'll see, this is VD0 by 2. Okay, this VD0 by 2, 1 plus cos alpha plus mu. Okay, for this one only it will be different. Other one, for other one, 2 pulse, 3 pulse and 6 pulse. What will be the output voltage? V naught will be VD0 by 2 into cos alpha plus mu. So this will be the output voltage equation for 2 pulse, 3 pulse and 6 pulse converter. Okay. 2 pulse means like full bridge converter. This is 3 pulse, 6 pulse. Okay. And what will the delta VD0? Delta VD0 will be same for all. Delta VD0 will be equal to VD0 by 2 cos alpha minus cos alpha plus mu. So what is VD0 here? VD0 for all the converters, VD0 equal to VO average at alpha is equal to 0. Normal, without source inductance, what is the average output formula at alpha is equal to 0? What we will get, that is called as VD0. So this formula only we have to memorize. Based on this only we can solve most of the numericals. Okay. And one more thing, like delta VD0 other formula is there. So for single pulse, it is F Ls I naught. For 2 pulse, it will be 4F Ls I naught. Okay. For 3 pulse, it will be 3F Ls I naught. And for 6 pulse, it will be 6F Ls I naught. Okay. So for 1 pulse already we have derived, that we got as delta VD0 as this one also in terms of frequency, source inductance and output voltage. So what we are observing? We are observing that in 2 pulse only it is multiplied by 2 times. Okay. Here one easily we can memorize this one. Single pulse means FLS I naught, 3 pulse means 3 FLS I naught, 6 pulse means 6 FLS I naught. Only exception is 2 pulse. So why in 2 pulse it is like this? Because the current will go from minus I0 to I0. Okay. So delta I is 2 I naught here. I will derive this one also, then it will be more clear. Okay. So can anyone tell me what will be the conduction angle of diode here? Diode will conduct for how much angle? Can anyone tell? Can anyone reply? Diode and thyristor, what will be the conduction angle for diode and thyristor? From this figure only we can see. Just already I have drawn here. What will be the, let's say I am telling like alpha is equal to 60 degree. Okay. And mu is equal to 5 degree. So what will be the conduction angle of diode? Can anyone tell? Hello, am I audible?
Yes, sir.
It's visible here, no? Clearly. Like from this waveform only we can say how much. Already I have drawn the thyristor current and diode current.
110 degrees, sir.
How? Like diode, how much it will conduct?
Sir, 180 minus alpha minus 2 mu, sir.
No, see. 180, what you are telling? 180 minus alpha minus 2 mu. See, previously what was the equation? Without this diode was conducting for pi plus alpha before overlapping, and thyristor was conducting for pi minus alpha. This already we have. How it will happen? See, here to here, this is alpha, this point is alpha, this point is pi. Okay, so pi minus alpha. But what is happening here? Here to here it is pi minus alpha. See, here to here it is pi minus alpha, but this extra mu is there. Okay, so in both cases what we have to do, we have to add the mu value. So diode will thyristor will conduct for pi minus alpha plus mu. Okay, and diode will conduct for pi plus alpha plus mu. Is it clear? See, for diode,
Yes.
here to here pi. Okay, for diode I am drawing here this line. Here to here pi, again here to here alpha. So pi plus alpha plus mu will be the diode, and pi minus alpha plus mu will be the thyristor conduction angle. Is it clear?
Yes, sir.
Maybe,
All these are equations for semiconductor, sir.
what?
Semiconductor, sir. This one equations you wrote now, sir. Single pulse, 2 pulse, 3 pulse,
No,
6
no,
pulse.
not for semi converter, other than normal converters. Semi converter, I think we have to do different. That analysis till now I also have not done. Okay, this
Uh-huh.
is for full bridge, not for semi converter. Semi converter, maybe the different kind of analysis will be there that we have to see. Depend on the configuration, like two diodes, sometimes two diodes, and maybe in next class I will do that analysis and I will discuss those parts also. Okay, I think that is not available in any book. Maybe if you will see any standard book, that semi converter with overlapping is not discussed anywhere. Okay, so I will analyze this part and I will come with in the next class with single phase semi converter. Okay, and that how mutual this overlapping will affect this one. Gate also they have not asked question till now. Based on this one also, like whatever this formula I have told, on this formula also in gate no question has asked till now, but maybe they can ask in upcoming years. Okay, so this kind of analysis you should remember. Simply they can give a question, they can give a data, they will ask what will be the conduction angle of thyristor or diode. It will be a fill in the blanks kind of question. Okay, so if you
Sir,
know this relation, directly you can calculate the mu and you can put in value and you can fill in the. So is it clear up to now? Should I proceed further?
hello.
Yes, you
Yes, sir.
can ask.
Sir, conduction angle we calculate in 2
Degree.
pi in not means in one period.
Yes, in one period, 2 pi, 2 pi. So here to here it is 2 pi. Okay, 1 second. Here to here it is 2 pi. So in 2 pi, how much duration it will conduct? Okay, in one cycle. So here one cycle is how much? 2 pi only. Is it clear?
Okay.
Okay. So I'm moving to a question.
Sir, for this we don't have 4 pulse, sir. 4 pulse convert.
Oh,
Single pulse.
no, 4 pulse is not there, I think. 4 pulse means in one cycle, 4 pulses is required. Which converter is 4 pulse converter? Full bridge is 2 pulse converter. Okay. Single phase single phase half bridge is 3 pulse converter, and single phase full bridge is 6 pulse converter. Okay. One pulse is this one. 4 pulse type of converter is not there, I think.
Okay, sir.
Okay. So this formula you have to memorize. This is the delta VD0 formula. Same delta VD01 formula is this one also. And this is the output voltage formula. Only one is different for single pulse. So for single pulse only this formula will be different. Otherwise this output voltage formula will be this one. Okay. So based on this only we can solve all previous year grade questions. Okay. I am going to solve the questions one by one. So this is the question asking I think 17 gate. Okay. So source inductance is there. Okay. Diode D1 and D2 is there. I naught is constant. So which one of the following statement will be true? Can anyone reply? What will be the correct option? Already we have seen in terms of thyristor and diode. This was the thyristor and this was the diode. So diode means what will be the value of the alpha for thyristor? Alpha will be 0. If this will be thyristor, same condition will happen where alpha will be equal to 0. Okay.
That means D1 equal to pi, sir. 180 degrees.
Which is the correct option out of 4?
D1 conducts for 180 degrees, sir.
180 degree or greater than 180 degree. Here overlapping is also happening. See, source inductance is there.
Oh,
LS is there.
So D1 conduction greater than 180 and D2 conductions 180 degree.
See, so I'm going to draw the waveform. Okay. First, I will derive with respect to formula. So what was the formula? Formula was pi minus alpha plus mu. And D formula was pi plus alpha plus mu.
mu.
So here, what is the value of alpha if this will be the thyristor?
0.
So if I am putting, so let's say this is D1 and this is D2. Okay. So D1 will conduct for pi minus 0 plus mu. Okay. And D2 will conduct for pi plus 0 plus mu. So what will be the angle? This will be pi plus mu and this one also be pi plus mu. So we will see both are greater than 180. This one will also be pi plus mu and this one also will be pi plus mu. I am going to draw the waveform also. So let's say first we'll draw the current. So D1 and D2. Okay. So here alpha, this is the source voltage. It means alpha is equal to 0. So 0 here only, but what will happen? It will do like this. Resistor current will go like this one, and this will go like this one. Again at here, what will happen? It will come like this one, and it will come like this one. Okay. So top one is D2 current. 1 second. Top one is D1, and bottom this one is D2. Okay. So if you'll see here, D1 is conducting from here to here. This is mu, pi plus mu. If you'll see D2 also. So D2, here it is pi, here to here it is pi, and this is mu. So both are conducting for pi plus mu. Is it clear? Can anyone reply? Otherwise, I will discuss again. This waveform is clear. See, this one is D1 and this yellow color is D2. Is it clear to all?
Yes, sir. Yes, sir.
Okay. So both will conduct for pi plus mu. So if some data will be given in the question, okay, let's say some data will be given, from there we will calculate the mu value. Okay, so the conduction angle of both the diode will be pi plus mu. So option A is the correct option. D1 conducts for greater than 180 degree and D2 will also conduct for greater than 180 degree. Okay. So I'm moving to the next question. Okay. So this is one question I have framed by myself. So alpha is given as 30 degree. Okay. Load current is 10 ampere. Source voltage is 220 50 hertz. So what will be the conduction angle of diode? We have to calculate. Okay. So how we can calculate? Anyone tell the steps? What should be the steps here? What
So
is
that one V naught VDC by 2 into 1 plus cos alpha plus mu. Mu we have to find, sir.
Yes. After that, already we have derived that formula pi plus alpha plus mu
Mu.
that we can apply. Okay. So V naught is equal to that value. What is what was that formula? Vm upon 2 pi 1 plus cos alpha plus mu. This was the formula.
Yes, sir.
But here, do we know the output voltage? We don't know, no? Here.
Yes, sir. Not given. 10 amps. You're given.
Our delta VD01 formula is there. Vm upon 2 pi cos alpha minus cos alpha plus mu. This is one formula is there. So what will be the delta VD0 here? One more formula was there, no? FLS I naught.
Yes, sir.
FLS I naught. So FLS I naught should be equal to Vm upon 2 pi cos alpha minus cos alpha plus mu. So from this equation we can calculate the value of mu. Okay. What is FLS I naught? So F is 50 hertz into LS 10 millihenry, I naught 10 ampere. This should be equal to Vm how much? 220 into root 2 divided by 2 pi. Okay. And here cos of alpha. So alpha means how much? Cos 30 minus cos 30 plus mu. Is it clear?
Yes, sir.
Okay. So what here it will be 5. Okay. So 5 should be equal to 220 into root 2 by 2 pi cos 30 minus cos 30 plus mu. Further, I'm going to write this on next page. So here it is 2 pi. 2 pi into 5. 2 pi into 5 divided by 220 into root 2 into root 2 equal to cos 30 minus cos 30 plus mu. So cos of 30 plus mu, this will be equal to how much? Cos 30 minus, this will be how much? When you calculate the mu value here. 1 second. We'll take the calci. So it will be 2 pi into 5, 2 pi into 5 divided by 220 into root 2. It will be 0.1. This I'm getting a 0.1 almost. Minus cos 30. So 0.765 it will be. It will be some value. The total will be 0.765. And if we take the inverse, so 30 plus mu will be equal to into, anyone have calculated the mu value?
40.08, sir, that one.
Hmm?
40.08
Okay,
minus 30 degrees.
40.08 we are getting. Okay, so
Sir,
mu
mu
will be
equal to
10.
10.08, sir.
Okay, so mu will be 10.08 degree. Okay, so
Uh,
now what will,
Conduction angle 180 plus
so D will conduct for
30 degrees.
180 plus 30 plus 10 point,
220.08, sir.
it will be 220.08 degree. And thyristor will conduct for 180 minus 30 plus 10.08. Okay, so it will be 160.08.
Yes, sir.
Okay, so this kind of question can be framed. Okay, this is one type of question. Is it clear up to now to all?
Yes, sir. We have to know virtual calculator, sir. This one.
With virtual calculator, this is easy only with virtual also.
Yes, sir.
It's easy only. Just you multiply this one and save in memory. Okay. Then you can do cos 30 minus this one. Then cos inverse. Then save in the memory. Then take the inverse of that one, cos inverse. Okay. So in calculator, I will recommend you all. You should more use the function memory save. MS, MS and MR. Okay. And M plus and M minus also you can explore. That is also an option. And 1 by X. If this all function you will use properly, then you will save your time in calculation. Okay. Should I move to the next topic?
Yes, sir.
Okay.
Sir, here thyristor will conduct less than diode.
Yes, it will conduct like that only.
Okay.
Already we have discussed this, why it is conducting less. Because here we'll see the waveform here. First only I have discussed. Diode will be pi plus alpha plus mu. Okay, and thyristor will, okay, here we have done reverse, I think.
Yes, sir, I have done reverse. We have done reverse.
Diode is more, na, 220.08. And thyristor is 160.08. So thyristor pi minus alpha plus mu. Okay, and diode pi plus alpha plus mu. Already this thing we have derived. I think
Yes,
it
sir,
will.
okay.
Okay, okay. So same thing I am going to do for two pulse converter. Okay, just a small derivation I'll do. So two pulse converter means it will be a one thyristor, and here it will be thyristor and one thyristor, and a source inductance will be there, Ls. This is source voltage, and here it will be like this, and this is I naught ripple free T1, T2, T3, and T4. So directly I am going to draw the current, and then after that I will draw the voltage. Okay. So first source voltage will be a sinusoidal voltage. So this is Vs, and this is 180 degree a part of Vs. Okay. And here I'm going to draw the source current. First thyristor 1, 2, and 3. So let's say this is alpha angle. Okay. This is alpha. Here also it will be alpha. So after alpha, what will happen? T1, T2 will be 0 previously. Okay. T1, T2. First I am going to draw the T1, T2 current. Okay. So T1, T2 will be 0 here, and it will go to 0 to I naught. Again, from here, it will go from I naught to 0. And similarly T3, T4. So this is T1, T2. T3, T4 will be conducting before here. At here it will go to 0. Again it will come here. And here it will go to, this is 2 pi. So what will be the source current? Source current is IT1 minus IT2. Okay. So what will happen? T1 minus T4. So this is T4 and T3. T3, T4. Okay. So what will happen here? I am going to draw the actual source current waveform. So here it will be, it will start from minus I naught. It will go to I naught. This is the source current, IS. Okay. And again here it will be plus I naught to minus I naught. So here it will be I naught, here it will be minus I naught. Is it clear to all? Otherwise I'll explain again why these currents are like this. So this is alpha angle. After that alpha, this is mu period. Directly it is not becoming 0. In ideal case, T1, T2 will directly become 0 to 1 here. But it is taking some time here. So this is the overlapping period. Okay. And this is source current. So source current means IT1 minus IT4. So IT1 this is, and minus IT4, then it will start from here minus. Okay. And here it will be plus I naught, here it will be minus I naught. Is it clear to all?
Okay, sir.
Yes.
That one.
Okay. So accordingly, the what will be the output voltage waveform? Normally, our output voltage waveform is like, first I'm going to draw the ideal case output voltage waveform. So that will be like this. It will be like this yellow color waveform. Okay. This is the output voltage waveform if overlapping is not there. But due to overlapping, what will happen during this period? Overlapping period. This all four are conducting. All four are conducting means output voltage will be 0. Okay. So this is the shaded region for which the output voltage will not appear. If 4 will be conducting, but this will be sorted across the output, so the output voltage will be 0. Is it clear? So during the overlapping period, all 4 thyristor will conduct 1, 2, 3, 4. Here also 1, 2, 3, 4. Is it clear to all?
Yes, sir.
So what will be the conduction angle of thyristor T1 or any thyristor? If alpha is the firing angle, what will be the conduction angle of thyristor T1? In ideal case, what will be the conduction angle without overlapping? Can anyone tell? For full bridge, it will be alpha to pi plus alpha. Alpha to pi plus alpha. What will be the duration? Duration will be pi.
Pi.
Okay, but
180 degrees, sir.
that is without overlapping. Okay. In ideal case, it will conduct from alpha to pi plus alpha. But see here, it is starting at
Yes, sir.
alpha.
Alpha 2 pi plus mu.
No, pi plus mu. Okay, see here. This is a starting point. Okay, up to here, what is the value? So this is alpha, this is pi plus alpha. So pi plus alpha minus alpha, that will be here to here it is pi, and here to here it is mu. Okay.
Okay,
So the
okay.
conduction angle of all the thyristor will be pi plus mu. I think it is clear to all.
Yes, sir.
Yes, sir. Yes.
Okay. So similarly in here, if all thyristor will on, then what we can see that this is plus minus Vs, this is VL. Okay. So this will be the a path if all 4 thyristor will on. Okay. So we can write that VL is equal to Vs to Ls dis by dt. Is it clear? for all this overlapping period, I'm going to derive delta V d0 here also. Okay. So for that one, alpha to alpha plus mu, the second point. So this will be the equation for the overlapping period. Since all four will conduct, it means we can say that the source voltage and inductor is sorted through this T1 and T3. Okay. And this VL will be equal to VS. This plus and this plus are connected together, and minus is connected together. So VL will be VS, will be LS DIS by dt. Okay. So same we can integrate Vm sine omega t dt, alpha to alpha plus mu. Is it clear up to now?
Yes, sir.
Okay. And this side will be Ls and dis. What is the is limit? So if you see the is, that will be minus I naught to I naught. Okay. So in other all converters, if you'll see this kind of equation, their current changing will be 0 to I naught. Okay. In other analysis like 3 pulse and 6 pulse analysis, if you see that this kind of equation, there what the current limit will be there 0 to I naught. But here if we are seeing, okay, so the limit is minus I naught to I naught. So here it will be minus I naught to I naught. That's why we are getting the final result as 4 FLS I naught compared to other. Okay. Already I have shown here summary. So if you'll see here, this is for 2 pulse converter, 4 FLS I naught is there. Okay. So that's why we are getting, because here source current is changing from minus I naught to I naught. Okay. So same thing we can do. I'm simplifying this one. Vm upon omega minus cos omega t alpha to alpha plus mu, and this side will be Ls into Is. Is what is the limit? Minus I naught to I naught. Okay. So it will be Vm. Here it will be like omega we can write as 2 pi. Okay. So here it will be cos alpha minus cos alpha plus mu. Okay. And this will be omega into Ls into 2 I naught. Okay. Both sides we can divide by some factor. Okay. So let's say I'm going to divide it by 2 pi. Okay. So it will be Vm upon 2 pi. Okay. Cos alpha minus cos alpha plus mu is equal to, what will be here? 2f Ls I naught. Is it clear? So here this 2 I am taking that side, because what is the V d0 by 2 for this kind of converter? V0 is equal to 2 Vm upon pi cos alpha. What is V d0? V d0 is equal to 2 Vm upon pi, and V d0 by 2 will be Vm upon pi. Okay. So to make that format, what I will do, Vm upon pi cos alpha minus cos alpha plus mu. This should be equal to 4f Ls I naught. Is it clear? Clear to all? Can anyone reply?
Yes, sir.
So see, what is this value? This value is V d0 by 2 for single phase full converter. Okay. So we can write V d0 by 2 cos of alpha minus cos alpha plus mu, okay, is equal to 4f Ls I naught. This is called as delta V d0. Okay. This already have it. So for this converter also we are getting the same thing. What is the output voltage? The output voltage is VO minus delta V d0. Okay, so this will be 2 Vm upon pi into cos alpha. This only. And what will be this value? Minus, this will be Vm upon pi cos alpha minus cos alpha plus mu. Okay. So this will be Vm upon pi cos alpha plus mu. Okay. So same thing we can write as Vo is equal to Vd0 by 2 into cos alpha plus mu. Is it clear? This thing already have summarized there. So this is the delta Vd0 equation for all the converters. Okay. And this is the output voltage for all the converters except the single pulse. Is it clear up to now? Anyone reply?
Yes, sir.
Okay. So some questions are there based on this only. That will take one by one. 1 second. So this is get 20 question. Okay. Is it okay if session will go for little bit more, like 30 minutes?
Yes, sir. No
Okay.
problem, sir.
Because questions are there, that will be more clear. Like after solving question only, it will be more clear. Okay. So this question is asking get 20. Okay. Single phase, full bridge, fully controlled thyristor rectifier fits a load. 10 ohm resistance is given in series with a large inductance. So the rectifier is fed from an ideal 230 volt 50 Hz sinusoidal source through a cable which is negligible internal resistance and total inductance of 2.28 millihenry. Okay. And alpha value is given. So we have to calculate the overlap angle. Okay. So this inductor value is given. Okay. This is the. So based on that two formula, we have to decide which formula we have to use. Okay. This highly inductive load and resistance value is given how much? 10 ohm. Okay. So this current is required. And here LS is given as 2.28 millihenry. Okay. So what formula we know? PO is equal to Vd0 by 2 cos of alpha minus, cos of alpha plus cos alpha plus mu. This is one formula. And second is delta Vd0 is equal to Vd0 by 2 cos of alpha minus cos alpha plus mu. Okay, is equal to 4f ls I0. Okay. So what will be the I0 value? Can anyone tell? I0 will be V0 by R, V0 by R. So this one we can put here. Okay. See, these two equations are there. So based on this only we can, this information, alpha information we have. Okay. Vd0 information we have. So if we'll put this first equation in second, okay, I0 will be V0 by R. Okay. So we'll get the simplified equation. Is it clear? Just I will put here that first equation. So I0 is equal to Vd0 by 2R cos alpha plus mu. Is it clear to all? After 2
Yes,
3
sir.
lines, it
VD
will
naught by 2, VD naught by 2 cancel, sir.
that will be cancelled. Okay. So I'm going to write the equation together. So Vd0 by 2, that will be cos alpha minus cos alpha plus mu. So cos alpha minus cos alpha plus mu is equal to 1 second 4f ls. So 4 into f into ls into I0. So I0 is equal to 1 by R into Vd0 by 2, okay, into cos alpha plus mu. So here Vd0 by 2, Vd0 by will cancel. Okay. So what will the value? Cos of 30 here minus alpha is how much? 30 only? No, 45. Cos 45 minus cos of 45 plus mu is equal to how much will be this value? 4 into mm,
50 into
2.28 milli,
2.28.
2.28 milli divided by 10. That only R is 10.
So
In
0.0456, sir. That one.
this one 0.0456. Okay, one
Ah, yes,
second.
sir.
So I will also calculate. Everyone will get the same answer. Then we'll proceed further. So 4 into 50 into 2.28, 2.28 into, and second, 10 to the power minus 3 divided by 10. By 10. So 0.0456 you are getting.
Ah, yes, sir.
0.0456 into cos of 45 plus cos alpha plus mu. 45 plus mu, we can say this one. Okay. So I will take one side. Okay. So it will be cos of 45, 1 minus 0.0456. This should be equal to cos of 45 plus mu. Okay. Into 1 plus 0.0456. Is it correct?
Mm-hmm.
This
Yes,
term
sir.
I am taking this side. So it will be cos 45 minus 0.0456 into cos 45. So cos 45 will be common. It will be 1 minus this one. And this side,
Sir, left hand side 0.674, sir.
and this one, how much we are getting? 0.674.
Ah, yes, sir.
So 0.674 divided by 1 plus 0.0456. 1 plus 0.0456. This cos inverse we have to take. Okay. So cos inverse of 0.674 divided by 1.0456. 1.0456.
0.6454, sir.
So cos inverse, how much we are getting? 49.86 we are getting something.
Okay.
This cos inverse of this one,
Inverse.
0.674 divided by 1.0456.
Yes,
This one I am
45.
getting as 49.86
Sir,
degree.
mu we are getting 4.8, sir.
Okay, so after this one, this is 45 plus mu. So mu will
Hmm.
be 49.86 minus 45. How much?
4.801, sir.
4.86 we are getting.
Okay.
4.86. This much we are getting. I think range is this. This is only the correct option. Everyone is getting this value 4.86. I think
Sir,
anyone is getting different.
no, sir. Actually, I have a
4.8.
doubt.
Okay, you can ask.
Sir, how did you write I not equal to V d0 by 2 cos alpha plus mu?
See, here already I have written two equations. Na? This is the output voltage equation. Okay. And this is the delta VD0 equation. So delta VD0 is equal to VD0 by 2 cos alpha minus cos alpha plus mu. This is equal to 4f ls I naught. What is I naught? I naught will be equal to V naught by R. Okay. So this V naught equation I kept here divided by R. Okay. So it will be 1 by R into this factor. So same thing I kept here. 1 by R. This 4f ls I naught. So I naught is equal to 1 by R into V naught. This is V naught. Is it clear?
Okay, yes, sir.
Simple only. See, 2 marks question. Just if you know these two equations, simply will put within 2 to 3 minutes, you will get the final answer. So final answer is
Yes, sir.
4.86 degree. It clear to all? So I move.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so I'm moving to the next question. So this is asking 17 2 marks only. Okay. So here asking what will be the conduction angle of the diode D1 in degree. So this is diode bridge rectifier. So in terms of thyristor, we can say that alpha is equal to 0. Okay. So how much conduction angle we got for the thyristor one? What will 180 plus mu.
Mu.
So here also it will be same 180 plus mu. Okay. So we can calculate the mu angle and then we'll add the 180 in that one. Okay. So see what information is given. So here 220 volt 50 hertz single phase draws I naught is given. The angle of diode D1 in degree. Alpha will be 0 degree. Okay. So delta VD0 will be equal to VD0 by 2 cos alpha is equal to, since alpha is 0, so 1 minus cos mu, this should be equal to how much? 4 into F into LS how much? 10 milli into 14. Is it clear? This equation is clear to all? Can anyone reply? See,
So
delta
that we
Yes,
get
sir.
1 plus cos alpha, no, sir.
no
I
cos
think.
alpha minus cos delta VD0 I am writing. So see this
Uh,
equation. First equation I am writing. So delta VD0 means cos alpha minus cos alpha plus mu. In
okay,
R2
okay.
voltage, it will be cos alpha plus mu. Okay.
Okay.
So here, since alpha is equal to 0, so the first term will be cos 0 is equal to 1 minus cos alpha plus mu. So alpha is 0 means it will be mu only. Is it clear?
No, yes, sir.
So what is this VD0 by 2 formula here? 2 Vm upon pi normally. So Vm upon pi. So Vm upon pi 1 minus cos mu is equal to how much this one? 4 into 50 into 10 milli into 14. 4 into 50 into 10 into 10 to the power minus 3 into 14.
28.
28. So this is 28. From here we can calculate the value of mu. Okay. So 1 minus cos mu will be equal to 28 into pi divided by Vm how much? 220 root 2. So cos mu will be how much? That will be 1 minus this value. So 1 minus 28 into pi.
Sir, we are getting cos mu value 44.17 degrees, sir.
Mu this much 44.17.
Yes, sir.
Okay. 1 second. Correct only 44.17. Answer I have written
Sir,
there.
that much it will convert, sir.
It depends on the that inductor value, source inductance.
Oh, oh.
Here inductance is high, 10 millihenry source inductance and load current. Okay. You can check the options. This is fill in the blanks type question, get previous year. You can check the question bank. Okay. So 120 into 5 by 220. Everyone got the same answer? So this will be 0.7172 something it will come.
Yes, sir.
0.7172, that will be 44.17 something. So mu will be how much? Mu will be 44.17. So what will be the conduction angle of D1? See, they are asking conduction angle of D1 in degree. What will be that?
224.17, sir.
Yes. So D1 will conduct for 180 plus 44.17. That will be 224.17. This will be the answer. See, this is also 2 marks question. Just if you know the formula, in 1 minute you can solve. I think 1 or 2 minutes, maximum 2 minutes it will take. You'll get the final answer. Okay. So, but whatever they have asked, other than that, different kind of analysis is required. Okay. Like they have asked for this one, but single phase that like half bridge that I have written there, like pi minus alpha plus mu, and that diode will conduct for pi plus alpha plus mu. That kind of question they have not asked. So every kind of analysis should be done. If they will ask new kind of question there in exam, you will not able to think that kind of thing. Okay. So before exam only we should be ready with different kind of analysis. Okay, this is the probability. So what can be the which type of question can be framed for this kind of concept. Okay, so that in that way you can collect different concepts. Okay, so if new question also will come in exam, that you will know previously only and you can solve that in less time. Okay, is it clear?
It's a clear, sir.
See,
Sir,
so
mu equal to I am getting 135.84.
how this equation only you have solved. 1 minus cos mu is equal to 28 into pi divided by 220 root 2. This equation.
Yes, sir.
How you are getting? So cos mu will be 1 minus 28 pi divided by 220 root 2. How much you are getting this value? Cos mu.
Cos mu, I
Cos
am getting minus
no,
0.7174.
something mistake you have done. 1 minus
0.7 something will come, sir.
okay
0.718.
0.28 pi divided by 220 into root 2. So this value will be less than 1 always. Okay. Are you
Yes, sir, I am
calculating?
getting 0.71.
Now 0.7, or if you will take the inverse, it will be 0.4 something. 40 point something, 40.17. You see some other
44.17, sir.
40,
44.
44.17. Okay. And that if you will add in 180, that will be 224.17. Okay. So some other kind of analysis also I have done, that it may be framed question based on that. So 3 pulse converter, okay, and 6 pulse converter. Normal operation. If it is mu is if it overlapping is there, what will the conduction angle for thyristor? So here thyristor will conduct for 120 degree plus mu. Okay, and here also it will conduct for 120 degree plus mu. This one I have analyzed. Okay, in next class, if you want, I will explain with waveform also. This one we have to memorize. Like first we'll calculate the value of mu. After that, if question will be what will be the conduction angle of thyristor. So normally it should be 120 degree, but if mu will be there, it will be 120 degree plus mu. Okay. So little bit overview I can give. 1 second. Let's say this is 3 pulse converter. So waveform we can draw like this. 1 second. So in this way, in exam, if you want to draw the waveform, in this way you can first draw the dotted line, okay, and then you can adjoin all the adjacent tips. So this will be the just reference voltage, okay. If three will be there, so 3 thyristor will be there, and with every thyristor, 1 inductance will be there, okay. So if effect will not be there, what was the two case in this one? Alpha less than 30 was there. So first I am doing alpha less than 30 only. Okay. So here A, B and C. A, B and C. So if alpha will be less than 30 degree. Okay. So here to here, what is this one? 30 degree. If it will go greater than 30, means what will happen? It will come on the discontinuous conduction. So alpha, let's say I'm selecting here. Okay. So here it will take the A voltage. Again it will B. Again it will C. And 2 pi is up to here. This is 2 pi. Okay. So if you see the current, here 1 is conducting, A means 1, B means 2, C means 3. Okay. So what will the current waveform? So for A if you'll see, this is the current waveform for A previously. Okay. Here to here. If there is no overlap, so what is this angle? This is how much? How much will be this duration? This is how much? Pi by 6. This is 120 degree, na?
120 degrees, sir.
Okay. So see, if overlapping will happen, then what will happen? So this 3 I3 current will not become suddenly 0. It will take some time and it will become 0. and similarly this I1 current will take some time and it will reach here. Okay. Similarly here, if also here 1 will change to 2. So 1 will not go suddenly here. What will happen? 1 will go down like this, and here this 3 will be 0 only. Here the current will be taken care by the 3. So 3 will start from here to here. So if we'll see the 1 thyristor 1, what is the conduction angle? So previously it was 120 degree, clear? And this is mu. Is it clear?
Sir, 120 plus mu.
So that will be 120 plus mu. Like this, we should analyze the new things. Okay. So that will be 120 plus mu. This kind of question can be framed. Like any data will be given. We have to calculate the mu. See, in exam pressure, you can not do this kind of new analysis. There you will do the mistake. So before going to exam only, we should do this kind of new analysis. Like whatever the possibilities will be there, in that way we should think. Okay. So let's say what will happen if alpha will be greater than 30 degree. Okay. So this analysis I am also doing first time now. Let's see. What will happen if alpha will be greater than 30 degree. So this step you should learn, like how to draw the waveform. Just one triangle, then triangle. This kind of triangle you can draw roughly. On pen paper it will be more easier. Like here on open board it is little bit difficult. Pen paper it will be easier. Like that you can make the tips. Okay, here you can make this tips. So alpha is greater than 60 degree. Okay, 30 degree. This here to here is 30. Let's say here. Okay. So it will go up to here. Let's say inductive load is there. Okay. So it will go up to here. Then also it will be same only. If freewheeling diode will not be there, no freewheeling diode. So what will be the conduction angle? That will be same only, 120 plus mu. Is it clear? Can anyone reply? See, if this is pi by 6 plus alpha. So here to here it is 120 only. This is 1. Okay. And after this the mu it will conduct. So it will be 120 plus mu. Okay. If freewheeling diode will there, what will happen? If freewheeling diode will be there, then what will happen? In this minus, it will not conduct. So minus will be here. Freewheeling diode will conduct. Is it clear to all? That thing I already 150 minus alpha. It was there like 150 minus alpha. Actual conduction was, for if freewheeling diode will be there, this is the 180. Okay, and this is how much plus alpha? 30 plus alpha. So 30 plus alpha. So what will be the conduction angle if freewheeling diode will not be, if overlapping will not be there? In that case, 180 minus 30,
160.
150 minus alpha.
Yes, sir. 150 minus alpha.
Okay. But see, but here what will happen? Here it will transfer to diode. Okay. So this current will go to diode from here to here. Okay. So in this case, I think two kind of that overlapping will be there. One will be between this thyristor to thyristor or diode to thyristor. I think diode to thyristor only will happen. See here in this section diode was conducting. In this section also diode is conducting. So diode. So what will be the angle? 150 minus alpha plus mu. This will be the answer. Is it clear? So alpha greater than 30 degree. Our answer should be this one. And alpha will be less than 30 degree. Alpha will be less than 30 degree. That will be 120 plus mu. Is it clear?
Yes, sir. Sir, this one are for no freewheeling diode, sir.
This is for no freewheeling diode. If freewheeling diode will not be there, for this case also it will be same. Okay, because this is 120 degree here to here, and 120 degree plus some mu it will conduct. So only for freewheeling diode case and alpha is greater than 30 degree, then
Um,
this formula is correct.
okay, okay.
Okay. So whatever will be the actual conduction angle, what is the observation? In previous also, what is the actual conduction angle? In that only we are adding the mu. So if you see here also, first case also, whatever was the actual, we'll go to the first. So see first, I will start from first. So here previously, if you'll see, 1 second, here. So see, what was the actual previous pi plus alpha, pi minus alpha was there. In that only we are adding the mu here. Okay. If you'll go to the full bridge. So full bridge also actual conduction angle was pi. Pi what we are doing? We are adding the mu. Okay. So here also same thing. 120 was the actual conduction angle. Okay. Here 120 and 120 we are adding the mu. But what is the freewheeling diode? With freewheeling diode actual conduction angle was 150 minus alpha. So in that we have to add the mu. So this should be the observation. Whatever is the actual conduction angle without freewheeling diode, in that only we have to add the overlapping angle. Is it clear? Almost it is same for all as per this analysis. Is it clear? Clear
Yes,
to all?
sir. But three-phase full wave also same, sir. This one.
The three phase full wave also. So for three phase full wave, okay. That analysis I have done. In next class I will draw that waveform. Then it will be more clear. So that is also normally it will conduct for 120 degree. Three phase full bridge.
Hmm.
As per we know that like I naught by root 3 and that things are there. Average and RMS. This is there no? For thyristor current. So it means it is conducting for actually 120 degree. What will be with overlapping? With overlapping it will be 120 degree plus mu. That will be the conduction angle with overlapping. Is it clear?
Yes, sir.
Okay. So with semi-converter, we have to see semi-converter there it is a different kind of thing. That analysis till now I have not done. So before next class I will do that analysis. Okay, and I will come up in the next class. So some more questions are there. 1 second. One question was there here. See this one. So a single phase fully controlled thyristor which converter is there, 25 degrees angle and 10 degrees of overlap. So what will be the fundamental, so displacement factor? What is the displacement factor? So normally what will be the current? Current will be like this, it will be minus to I naught. Okay, so this is alpha angle. If you see the fundamental current, that will start like this one. Okay, this is the shape of the fundamental current. Already Fourier analysis I have done for this one also. So this will be the fundamental current. So if you see the angle from the starting, this is the reference source voltage angle. So this is alpha. But what will happen if overlapping will be there? So in case of overlapping, the current shape will be like this one. It will not be this one. Let's say this is mu. Okay. So it will start from this one. It will go like this one. Then here it will come source current, and this is mu angle. Then it will come here. Okay. So if you see the fundamental waveform, there it will cross at middle of this one. Okay. So this will be the fundamental waveform current. If we do the Fourier analysis. So what is the displacement from here? That is alpha, and this part half part is mu by 2. Okay. So we'll say that displacement angle is alpha plus mu by 2. So what will be the displacement power factor? That will be cosine of alpha plus mu by 2. Is it clear? Can anyone reply?
Yes, sir.
So what will be the value? It will be alpha how much? 25 plus 5. So cos 30. Cos alpha is 25, mu by 2, 10 by 2, so 30. So it will be 0.866. C is the correct option. Okay. Some good questions are there. Like should we solve some more questions like first, like some very few sessions are remaining. Like I'm planning to cover the inverter part also. 2-3 sessions more I will take. Okay. So
Yes,
inverter
sir. We
also.
can solve, sir.
Okay. Okay. So see, what is the inductive voltage regulation? This is one question. One term is there, inductive voltage regulation. So inductive voltage regulation means whatever will be the delta VD0 that is divided by actual voltage without that one VU at some particular alpha. Okay. So this is called as inductive voltage regulation. What is the drop caused by the inductor divided by the actual voltage without the inductive effect? Okay. So this will be VD0 by 2 into cos of alpha minus cos alpha plus mu. Okay. Divided by what is the this value? 2 Vm upon pi into cos alpha. Is it clear? This will be the regulation. Similar to transformer, like no load without inductive effect, what will be the output voltage? So drop divided by that actual voltage. Is it clear? So what is this VD0 by 2? VD0 by 2 means Vm upon pi. Okay. So this will be, this factor will be Vm upon pi. So it will be, final will be cos of alpha minus cos alpha plus mu divided by, it will be 2 cos alpha. So this will be the regulation. Okay, we know the alpha value, we know the mu value. Okay, so now we can calculate this one. So it
Sir,
will
for regulation, we will find like no load minus full load by full load, no, sir.
no, here it will be little bit different. Like without drop, whatever voltage we are getting, this is the actual voltage without drop.
Oh,
Okay,
okay.
actual voltage without drop, and means no drop is there. What will be the output voltage? Due to this inductive nature, some drop will come. So that
Oh,
drop we are keeping at top, and this voltage without drop we are keeping at bottom. Okay, this will be the, it is similar kind of thing. Like there also, if no load will be there, drop will not be there. Okay, same source voltage will go at the load voltage. Okay, if load will be there, then drop will be there. That drop only we are keeping at top, and bottom will be without drop voltage. Is it clear?
yes, sir. Yes, sir.
So cos of how much? Alpha 30. Cos of 30 minus cos of 33.7 divided by 2 into cos 30. How much? 0.01967 we are getting.
Sir, but I have one doubt, sir.
Okay, you can ask.
Sir, how we got that cos alpha minus cos alpha plus mu by 2 cos alpha, sir? Is there any
See,
cancellation, sir?
no, see here. So VD0 by 2 means, what is VD0 for this one? Vm upon 2 Vm upon pi.
Oh,
Okay. And VD0 by 2 will be Vm upon pi.
yes, 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 sir. Got it,
For
got it.
this one, 2 Vm upon pi into cos alpha, actual
Cos
voltage.
alpha.
What is the
Uh-huh.
VD0? VD0 alpha is equal to 0. So that is 2 Vm upon pi. And VD0 by 2 will be Vm upon pi. Okay. So Vm upon
Okay,
pi
okay,
will
sir.
cancel. Then it will be, here it will be like this. Is it clear?
Yes, sir. Clear, sir.
Okay. So this one concept you should remember. Like this can be question also asked in the exam. Maybe sometime they have asked also. Everyone, this question is clear to all? Should I move to the
Mm.
next?
Yes, sir.
Some other good questions are there. So see, this one. This is a new variety of question. Like same, output voltage will be same as single phase full bridge. Okay, single phase full bridge. But the current will change from 0 to I naught. Here current will change from, in single phase full bridge, what was happening? Current was changing from minus I naught to I naught. But here what will happen? Current will change from 0 to I naught. So delta VD0 equation will be 2F LS I naught. Okay. here output voltage will be same. So see, two voltage source are given, VS1 and VS2. Both are 120 degree apart. So this is VS1, this is VS2. Okay, this is source current, this is also source current. Okay, so what will happen? This is the load current. Okay, load current, sometime it will be shared by T1, sometime it will be shared by T2. So if I am triggering at alpha, let's say this is alpha. Okay, this is alpha. So before here, T1 current will be 0. It will start from 0 to 1. Again, it will go from here to here. And here also, if you see, T2 will start from I0 to 0, and it will go from 0 to this one. So in previous case, what we have seen that current was going from minus I0 to I0 for full bridge rectifier. Okay. But here also output voltage will be same, because if we are triggering T1 at alpha, so normally output voltage will be like this one. Okay. It will conduct till will trigger T2, and here it will be same. This kind of waveform will be there. Okay. So here also we'll get the same formula, delta VD0 equal to VD0 upon 2. Same we will get cos alpha minus cos alpha plus mu. This will be equal to 2f ls I0. Why? Because our current is changing from 0 to I0. Is it clear? This will be the drop in the output voltage, mu duration.
Okay, two pulse, sir. This one formula.
This is two pulse. Same. See here already the separate two sources are given. That both
Mm-hmm.
sources are. This is not a single source converter. So two sources are given, separate sources.
Mm.
That sources are 180 degree apart. Means if this will be positive, this will be negative, this will be positive. So if in this cycle, if we are triggering this one, then this will trigger, and output voltage will taken care by this one. So waveform will be
Mm.
same as that of previous one, but if we are seeing the source current, IS, okay. So that if we are seeing a thyristor current T1, okay, so this is T1. T1 is going from 0 to I0. Okay. So if you write the KVL equation during the overlap means T1, T2 both will conduct. Okay. So if you write the KVL equation, what is the KVL equation? VS1 minus LS di1 by dt is equal to how much? V0. And second also will be Vs2 minus Ls di2 by dt will be equal to V0. Okay. So if you subtract 1 minus 2, what will happen? This both are 180 degree apart, so it will be 2 Vs minus Ls, okay, and di1 by dt plus dfi2 by dt. Okay, should be equal to 0. Is it clear? These equations which I have written here. See why this is 180 degree apart means this is angle 0, so it will be minus. Magnitude, if you'll see in phasor, it will be minus. So that's why 2 Vs I'm writing here. Is it clear?
Okay, okay. Okay, sir. Clear, sir.
And here Ls into di1 by dt. So another thing is there, I1 plus I2 is equal to I0. That I0 is constant. So you can say that di1 by dt is equal to minus di2 by dt. Is it clear?
Mm. Mm, yes, sir.
So we can write this equation as 2Vs minus this this will be minus LSDI. This will be also 1 second. It will be plus now, like minus. It will be plus here, I think. So Ls di1 by dt. So minus di1 by dt plus di2 by dt. I think this only na. Plus otherwise we can write plus. So d first minus second we are doing. Okay. So this will be plus. I2 will be plus. I1 will be minus. Minus d1 I1 by dt plus di2 by dt. Is it clear? So di2 will be equal to di1 minus di1. So we can write 2Vs minus Ls 2 ls di1 by dt is equal to 0. Is it clear?
Hmm.
This one.
Yes, sir.
So Vs will be Ls di1 by dt, and if we'll see the I1 waveform during the mu duration, what will happen? That I1 is 0 previously during the mu, so this is alpha and this point is alpha plus mu. So it is going from 0 to I0. That I1 current, here I have drawn this I1, IT1 or I1, is going from 0 to I0. So what will be the equation? So Vm of sine omega t, okay, into dt, alpha to alpha plus mu equal to how much? Ls into di1 0 to I0. Okay. So there what was the, in first case, like normal full bridge, it was minus I0 to I0. Okay. That's why we got 4 FLS I0, but here it will be I0 into Ls. Is it clear? Remaining thing will be same as previous one. Is it clear now? So that's why delta Vd0 equal to Vd0 upon 2 into cos alpha minus cos alpha plus mu is equal to 2f ls I naught. Is it clear?
Yes, sir. Clear, sir.
Okay. Now we can solve this question. So see what is given: 120 degree RMS, 60 Hz, 45 degree. Okay. So overlap angle we have to calculate. So how we can calculate? That same equation we can apply.
2FL, 2FL.
Yes.
Yes, sir. That one.
So Vd0 upon 2 cos alpha minus cos alpha plus mu. This should be equal to 2f ls I naught. Okay. So we'll see what is the value. F 60, I naught 10, and ls is not given. 1 second. I'm missing
Not
something.
given, sir.
Okay. 1 second. Where it will be there. Anything we can say. Okay. Like method is clear. So we can see it later also. Maybe some question was there. Maybe data I am missing. Where it will be there. Let's say 10 millihenry only it will be. Anything we can calculate. Okay. So what will be the value? 2 into 60 into 10 milli into how much output current? 10 ampere. 10 ampere. Okay. Vs is 120. Alpha is given 45. Okay. So cos 45 minus cos 45 plus mu. Okay. And Vd0 by 2 how much? Vm up to Vm upon pi. So Vm upon pi this will be 120 into root 2 divided by pi. Is it correct? How much this side value?
12, sir. That one.
This one 12. Okay, 10.
12.
So it will be 12. So cos of 45 minus cos of 45
12
plus mu. This
by
should be equal to 12 into pi
120 into root
divided by
2.
120 into root 2.
So that one left hand side, right hand side 0.222, sir.
This is 0.222.
Hmm.
Okay. So cos 45 plus mu. This should be equal to cos 45 minus 0.222. Correct? So
Yes.
cos inverse cos
That one
45
0.48, sir.
and 0.222. So what will be the inverse? I'm getting 60.98.
Okay, okay.
60.98.
Sir, 60.98
So this is 45 plus mu.
minus 45.
So mu will be
15.98, sir. Mu.
okay. So 60.98 minus 45, that will be 15 point.
98.
Okay, 15.98. So this, you know the concept, like this way you should remember. So this is another variety of question. Okay. If this kind of question will come, you should be careful. Like there we will use 2FLS I naught. Okay, one second. This is also a good question. Should we solve this one also?
Yes, sir.
Like already I have taken some variety of questions, like such that everything will be clear. Like next class in 3 phase more questions I will discuss. 3 phase
Sir,
also
we
one.
can complete this question, sir.
Okay, we'll complete these questions. See, GATE exam means you should solve maximum variety of questions, like different type of concept if you'll cover, like if similar kind of question will come, you can solve that question in less time. Okay. See, so this question is there. What is the given data? Input voltage is a square waveform. This is different. I think this analysis will be different. Okay, and this I will solve in the next class because this is totally different. Input voltage will be a square waveform. That analysis will be different. So this analysis, I thought that this will be a normal question, but since this is a square waveform, we'll solve this question in the next class. Okay, moving to the next question. Okay, so see here. The equivalent circuit of single phase full converter is shown in the figure. The net average output available across the terminal X and Y, so average voltage, okay, is 200 volt and load current is 1 ampere. This I naught is 1 ampere, constant current. The source frequency is 50 hertz, then what will be the value of the source inductance? Okay, so output is given. Which formula we can apply? So V naught is equal to VD0 by 2. Okay, cos alpha minus cos alpha plus mu. Is it clear? Hello.
Yes, sir.
And delta VD0 will be VD0 upon 2 cos of alpha minus cos alpha plus mu. Okay. So what they are telling that 2 Vm upon pi cos alpha. Okay, the source side voltage. This should be after some drop. So how much is the drop? How much is the delta VD0 here? We are getting 20 volt. Clear? This is this one. Output voltage we are getting at this one.
Okay. Drop is 20 volts.
Drop is
Sir.
20 volts. So this we should equal with 20. Is that clear?
Yes, sir.
So what should be the alpha value? From here we can calculate alpha, I think also. 1 second. This 1 ampere is there, no? So okay. See, this drop we got already. So what is the value of this one? 4FLS I naught. This only I naught is given.
I naught 1 ampere given, sir.
And frequency is given.
50 H given, sir.
So 50
Unless
into
we have to find.
50 into 4. Okay. How much?
Sir, it is one pulse converter, right? I think.
No.
Single
See,
phase
single phase full
converter.
converter. Here it is given as 2 Vm upon pi cos alpha. This is for single phase full converter. So actually they are saying that at some particular alpha we are getting this value, but output value we are getting this much due to some overlapping part. Okay. So how much is the drop? Drop we are getting delta VD we are getting 20 volt. Okay. This 20 should be equal to 4 FLS I naught, I think. So 4 into 50 into LS into I naught how much? 1.
50 into 1.
So 200 into LS. 200 into LS, this should be equal to how much? 20?
Sir, 0.1 Henry, sir.
Yeah, yes, this is the correct option. See, just very easy question. They have framed in a different way. Just we know this value, then 4FLS, I no need to solve it. So we have to see which formula is required to use. 20 here, this should be equal to 4 FLS I naught, and this will be 0.1. Is it clear to all?
Yes, sir.
Okay, okay. I am moving to next questions. Many questions I have taken in, and other questions are also there. 1 second. This is 3-phase question. 1 second. This. Okay. MA. Okay, this question we can try. 1 second. See,
Mm.
this is given in a different language. Like power converter is supplying 3 kilowatt power. Okay, 3 kilowatt power to the
Mm.
load. I naught is constant. LS is 5%. So all of you know the concept of per unit. What is the concept of per unit voltage?
Here given 0.05 Henry, sir.
No, not Henry. 0.5%. So 5%
Oh,
means
okay.
0.05 pu.
Oh, okay, okay.
Okay, that will be 0.05 pu. Is it clear?
Yes, sir.
Okay. Like no, here not LS. This is XS. So
Oh,
X
okay,
means
okay.
2 pi FL. Na? That will be 2 pi
Mm.
F into L. So that is given as 0.05 per unit. Okay. So what will be the actual X we have to calculate? So here if you'll see a kVA is given, rated kVA is 5 kVA, okay, and rated voltage is 230 volt. So what is the Z base? Z base is kV base whole square divided by MVA
MVA.
base. Okay, what is the kV? 0.23 whole square by what is the MVA? How much it will be? It will be 5 kVA divided by 1000. So how much? 0.005 MVA. Is it
Mhm.
correct? What will be this value? 0.23 whole square,
10.58, sir.
10.58. Okay, it will be 10.58. So what will be the actual value of the reactance? X will be 10.58. Actual X will be 10.58 into how much? 0.05. This will be the actual source reactance. How much it will be?
0.529, sir.
0.529. Okay. So we have calculated the reactance 0.529. What will be the inductance? So 2 pi
Sir.
into 50. This should be equal to 2 pi f into L. Okay. Equal to 0.592.
529, sir, that one.
529. Okay. 529.
Mm.
529. How much will be this value? L value. So see 2 pi f L is equal to how much?
100
0.529. 0.529. So how much is the value for this converter? 4FL. We have to calculate
Sir.
4FL. So what will the
Mm.
value of 4FL? So 4FL will be 2 into 0.529 divided by how much? Pi.
Into-
So for this one, full converter, what factor is required? 4FLS I naught. This factor is only required for this one.
Mm. Yes,
This
sir,
fact.
yes, sir.
So we can directly calculate 4FL value. What is the 4FL value here? 2 into 0.529 divided by pi. How much it will be? 0.33677. So from the given reactance data, step 1, we have calculated this value. Okay. 4FL value
Mm.
we have calculated. So now what other data is given? Output power is given. Okay. So we'll write the first two equations. For any question, First, we'll write the two basic equations. So V naught is equal to V d0 by 2 into cos alpha minus cos alpha plus mu. So step 1 is we'll write these two equations, then we'll figure out how to use this equation. Okay. And delta V d0 is V d0. Okay, this is here it will be plus V d0 by 2 and it will be cos alpha minus cos alpha plus.
Mu.
Okay. And other information is given as output power. P naught is given 3 kilowatt. What is P naught? P naught we can write as V naught into I naught. Okay. This information is given, and this is what 4 FL I naught. Now we can use this information, like we can put in each other. So what will be the P naught from here? If you'll see, I naught we can derive from here. So I naught will be 1 by 4 FL into V d0 by 2 into cos alpha minus cos alpha plus mu. Is it clear? From this equation.
Yes, sir.
So what will be the output power? Power will be V naught into I naught. Okay. So power we can write as, this will be 1 by 4 FL. So 1 by 4 FL into V d0 by 2 whole square. Okay. And this is A plus B into A minus B. What will be? A square minus B square. So that will be
Cos square alpha
cos square
minus
alpha minus
cos square alpha plus mu.
alpha plus mu. So this will be the output power equation. It clear up to now? And alpha value it is given already there. Alpha was 30 degree. Okay. And output power how much? 3 kilowatt. So 3000 we can write here into 1 by 4 into
Equal to
it will be equal to 3000 is equal to 4 into 50 into how much? L value. Okay, 4FL already we have calculated now. How much that value was?
0.033 something like that.
0.3677. Okay.
Sir.
So it will be 0.33677 into V d0 by 2 how much? Vm upon pi. So Vm how much here? 230 into root 2.
230 into root 2.
230 into root 2 by pi whole square into cos 30 square minus cos 30 plus mu whole square. So this equation only we have to solve to find the mu value. Okay. So it will be 3000 into 0.33677 into pi square. Okay. Divided by 230 square into 2. How much? It should be equal to cos square 30 minus cos square 30 plus mu.
Sir, left hand side 0.094, sir.
0.094
0.94.
minus cos square 30. No, cos square 30 minus this one.
Sir.
So cos square 30 plus mu
Cos square 30.
is equal to cos square 30 minus 0.094.
30 root 3 by 2. 3 by 4.
How much you are getting?
3 by 4.
So this will be under
0.655, sir.
this value. We are getting 0.655.
Yes, sir.
So we have to do a square root of this one. That will be cos 30 plus mu. Cos 30 plus mu. That should be equal to 0.655 under root. Okay. Then we have to take inverse of this one.
0.809, sir. That one, root, under root.
Okay. So cos inverse 0.809. That will be 36. We are getting as 36 degree.
No, sir. 35.9 means 36. Okay, sir.
36 degree we are getting. So what will be the mu value? mu will be
6 degrees, sir.
so mu will be 6 degree. That is the correct option. Mu is almost 6 degree. Now we can calculate the average voltage also. Average voltage was also asked there, I think. So that you can calculate by yourself. It will be the average voltage. That, like, already we know the value. So average voltage will be Vd0 upon 2 into cos alpha plus mu. Okay.
Mm-hmm.
So first we'll calculate the mu value.
2
Okay.
5 into cos
230 into root 2
plus
by
cos
pi cos
51.
30 plus cos 36. That only, no? Alpha was how much? 30 only? Okay.
Oh,
So this will be the output voltage. 230.
30, 36.
So 230 into root 2.
So 173.42 also.
Correct. So that is 173.4. Correct only. This only answer I have written here. So this is the final answer. On 3-phase also I have taken. So this is the last question, I think. So already formula we know. Should we practice this one also? Next class I
Yes,
will
sir.
come with more question. Okay. So see, what is the output voltage equation for 3-phase? Total DA will be 3 VML upon 2 pi cos alpha, which you remember?
Yes, sir. Yes, sir.
3 Vm line to line upon pi 2 pi. For full bridge, it will be 3 VML upon pi cos alpha, I think. For this kind of converter, it is 3 VML upon 2 pi cos alpha. Okay. So what will be Vd0? Vd0 will be 3 VML upon pi, 2 pi. And Vd0 by 2 will be 3 VML upon 4 pi. Is it clear? This will be Vd0 by 2. Okay.
Oh, okay, sir. Sir,
So
but
see,
here alpha is 45 degrees, sir, greater than 30 degrees.
that is okay. Anything will be there, but this equation will be same.
Mm-hmm.
What will be the alpha value, but this kind of equation will be same. That conduction angle will only change. Like thyristor conduction angle and that conduction angle will change, but that formula will be same only. Okay.
Okay.
That formula will be same only. So that Vd0 by 2. So already what is given there? Phase RMS value is given. Phase voltages VA, VB, VC have the RMS value of 120 volt, 60 hertz. LS is 5 millihenry. I naught is 10 ampere. Okay. So the average value of V naught and commutation. So this we have to calculate. Okay. So what is delta Vd0? Delta Vd0 is equal to Vd0 upon 2 into cos alpha minus cos alpha plus mu. So this delta Vd0 we know how much it will be. 3 FLS I know. This is 3 pulse converter. So 3 FLS I know. Okay. So 3 into how much? 60 into FS how much? 60.
5 million.
LS how much? 5 milli.
5 million.
5 milli into I know 10. How much this value?
9, sir.
This is 9. Okay. So Vd0 by 2, I will again write. So what is the Vd0 by 2 here? 3 into VML. So this phase voltage is RMS value. So what is the line voltage? Line voltage is 120 into root 3. Okay. Root 3 times the phase voltage, line voltage. And what is the peak value? So peak value into multiply by root 2. Okay. So 120 into root 6 is the maximum line to line voltage. So 3 into, here it will come 3 into 120 into root 6 divided by 2 pi. Okay. So, but V0 by 2 will be 4 pi. So 3 into 120 into root 6 divided by 4 pi. This is VD0 upon 2. VD0 upon 2 into
Mm.
cos of how much? 30. 30 is the angle, no, 45. Cos of 45 minus cos 45 plus mu. This would be equal to how much? 9. Okay.
9
So now
divided
we
by
can
9
calculate the
sir.
mu from here. So cos 45 minus cos 45 plus mu. This should be equal to 9 into 4 pi divided by 3 into 120 into root 6. How much?
Sir, right hand side 0.128 sir.
0.128. Okay.
8.
So cos 45 plus mu is equal to cos 45 minus 0.128. Okay. And this cos inverse we have to take. How much this one?
0.128. 0.579 sir.
0.579. So this will take the cos inverse. So cos inverse 0.579. This is 54.61.
Sir.
So mu will be 54.61 minus 45.
Mu equal to 9.61 sir.
Correct only. So mu value is 9.61. Correct. Mu brow is equal to 9.61. So what will the average value? Average value is equal to V naught is equal to VD0 upon 2 cos alpha plus mu. This one I think 99.2 something will get. We can solve now only. So VD0 upon 2 means 3 into 120 into root 6 by 4 pi into cos 45 plus 9.61. How much? Cos 45 plus cos 45 plus 9.61.
90.25 sir.
Correct, 90.25. This answer I have written only previously. So 90.25 is the answer. So should I summarize the formula once more? Like it will be a revision kind of thing.
Yes sir.
So delta VD0, okay, is equal to VD0 upon 2 cos of alpha minus cos alpha plus mu. This one formula we have to remember. Okay. Or 1 pulse, 2 pulse, 3 pulse and 6 pulse. What is the delta VD0 value? And the delta VD0 value will be delta VD0 in other formula will be this is F ls I naught. This is 4 F ls I naught. This is 3 F ls I naught, and here it will be 6 F ls I naught. So this we should remember. This is for all converter. Okay. And V naught will be VD0 upon 2 cos alpha plus mu. This is for all converter except the single pulse. For single pulse it will be VD0 upon 2 1 plus cos alpha plus mu. This only was the formula for single pulse, I think. Already we have derived. We'll go to the starting. 1 second. 1 second. So here I have derived it. 1 plus, okay, 1 plus cos alpha plus mu. So this is VD0 upon 2 only, 1 plus cos alpha plus mu. Okay, correct only. So this is the summary, like this much we should remember. This is the summary, we'll remember this one. Every type of this kind of question we can solve. And everywhere what will be the actual conduction angle in normal conduction, there it will be actual conduction plus mu. That will be the conduction of that thyristor or diode that we have observed. Okay. Like for 3-phase 120 degree plus mu. Okay. For single phase full bridge 180 plus mu. Okay, so this PDF I will share, like you can revise from this one. And other type of one variable we have single phase only, single phase two source was there, two source. There it was FLS, 2 FLS I naught. That you have to remember. Is it clear? This is the summary. Like based on this only, you can attempt all the questions. You'll get the answer. So next class, three phase some more waveform I will explain. Okay, and based on this question, some other question I will explain, and I will start the inverter portion. Okay, because inverter is a very like not a very vast syllabus, so that I will cover with respect to gate syllabus. Okay, I will cover that much so that you can solve all the gate questions. Is it okay?
Okay, yes, sir.
So some 2-3 sessions I will take. Maybe sessions will be more only because I have to complete the syllabus. Okay. So inverter I will cover all a different kind of analysis which I have done. Okay. So that also I will share with you. Like in different current ratio is there. Like if load current will be given, what will be the thyristor current? Okay. That kind of separate analysis I have done during the preparation. So that I will all thing I will share with you. So maybe if it will be required, can I take classes on other days also other than Monday? If all of you will
Yes,
be
sir.
agree.
Tomorrow, no class, sir. Tuesday.
Okay, so not tomorrow, next Monday and Tuesday directly 2 days I will take the class. Okay.
Okay, okay, sir.
Till then, what you can do, you can revise this. You try to solve all the previous year rectifier questions. Okay. So then, like gate previous year, all questions should be solved by you, all previous year. Out of that, whatever you are not able to solve, that you tick mark and send in the group. Okay. Such that whatever you are facing difficulty, that question I will solve in upcoming sessions. Is it clear?
Okay, sir.
So before my next session, you should solve all the questions. But wherever you are getting the rectifier questions, all you should practice such that if you have doubt, it will be clear in the next session. I think is it okay?
Okay, sir.
Okay. So next classes, two classes I will take Monday and Tuesday. I will take 2 hours classes. I will take Monday and Tuesday. Okay.
Okay, sir.
Okay. So thank you all, and happy
Hello,
Makar
sir.
Thank you very
Sankranti.
much, sir.
Hello.
Yeah. Yes, Deepak, you can ask.
Sir, can you please send me some notes, like whatever you will teach, so that we can previously review that notes so that we can understand easily?
Okay. So see, this kind of thing, I not there daily basis. I am doing analysis. Some new kind of analysis. If I am doing that one like this, something today I have discussed that previously I have not done the analysis. Okay. So many things will be new, but some existing things will be there that I will share. Okay. Some basic things I will share, like basic. Okay. Some PDFs are there that I will share before. So then it will be more clear, I
Yes.
think. Okay. Okay. Some short
Yes.
notes I have made that PDFs are there that I will share.
Yes, sir. Sure,
Before
sure.
next class, I will share that. But before that one, I will share this PDF and you should go through all the previous year question. Okay, then this session will be successful, I think. If you are able to solve all the questions, then it will be very good. So you solve
Yes,
all the
sir.
previous year rectifier questions. Okay. Other questions also like DC-DC converter, I have taught every question you try to solve. So if any doubt will be there, one to one it will be cleared. Okay. You will post the question in the group. I will take that question. I will discuss in the next class. Okay, so thank you all and happy Makar Sankranti to all. Thank you.
Same to you, sir.
Thank you all.